So, when we are graphing logs, when we are graphing logarithms, there are a few rules that you have to follow. Now remember, your graphing calculators themselves will be able to do a lot of this work, but you have to know how to set it up. So the graph of every log function has the following characteristics. Notice, we have an h and a k. Every log has the following information. In logarithm graphs, you are always going to have vertical asymptotes. Vertical asymptotes, they go up and down or left and right. Up and down, good. Now, the vertical asymptote for every log equation is going to be where x equals h. Okay? Oh, that's right, Donkey. I told you yesterday I was going to do it.
Oh, I didn't remember.
The domain for these things, the domain on all of our log stuff is going to be x is greater than your value of h. Okay? The range is going to be all real numbers because there's no boundary going up or down on these graphs. They're just going to be stopped from going too far in one direction. Right? There's going to be a stopping point. And then the other part is whether it's going to be moving up and right or down and right. If your base, the b value, is greater than 1, it moves up and right. If b is between 0 and 1, it goes down and right, and we have no negative bases. Okay? So that's what basically every one of these graphs is going to look like. Okay? Not so scary? So let's look at one. Let's say we've got the log of 1/3, or base 1/3 of x minus 1.
Is that x like a regular x, or is that like an x to 1/3?
It's a regular x. Yeah, actually you're saying that 1/3 is the base of the logarithm. No. There won't have to worry so much about that. So let's take a look at how this goes. What is your value of h? What is your value of k? Kind of a trick here. The h values are always going to be in parentheses. Is there an h?
No.
That's awesome. All right, here's a trick. Do you guys see any parentheses in this problem? No, there's no parentheses. There's no parentheses, there's no h. H is 0. Your k value is what? -1. Your b value is 1/3. Since the b value is 1/3, that means it's between 0 and 1. So the graph should look like this. Okay? So now when I go to my graphing calculator, Now, the one I have on my board doesn't allow me to do my log base. So you guys all know how to change the base in your calculator. If you hit the math, go to your y equals first. For notes wise?
Yeah.
I would. This stuff is kind of like a nutshell of what's in the book. It's kind of like the parameters of all the graphs, okay? Now, first thing you do, go to y equals, and then hit math, and scroll through to find out where it says log base. Yeah, I think it's the second to last one. Okay? Now, when you do that, you should get log, and you should have like a box area where you can change your base, correct? Does everybody see that? Put in parentheses 1 divided by 3. Put that base in parentheses as 1 divided by 3. And then inside the x value, you're just going to put x. Now, since there's no h, you got to get out of the parentheses minus 1. It should work. Okay, it should work. Really? Window range. Oh, that just means the window range messed up? Oh, you're fine. When it says window range, you know, it says minimum, maximum, they're the same number. There's a problem. What? That log base changed. That's weird. I don't know why it's not doing log base here. I'm sorry, let me bring that. What's an error? Why are you erroring? You're erroring not too? It's just moving. It's moving towards that. I just meant it's moving towards the right. That's all. It could be. It could be. All right. I'm just saying it's just going towards the right. That's all. That's all. Yeah. When I wrote that through, I didn't want to screw everybody up. All right. So what happens? What's happening here is you should get, now when I have this, remember, this is going down to the right here, or it could still go like this because it's still going down to the right, okay? So it could be either one of those shapes. When you go to yours, is yours working on the...
Yeah.
What do you got? No, because if you put the x minus 1 in the parentheses, it's assuming that it's the h value. When you see a problem, if you will see a parentheses, that means that's the h value. If you don't see parentheses, it's the k value.
So I have access on the outside of it.
Correct. Correct. And why it's not working for yours is beyond me. It shouldn't. That won't have any issue because this is a non-trig function. They won't have any issues. It's non-trig. So when you get to this point now, most of you guys' graphs should look something like this, right? Some along those lines. If you're doing that correctly, it should be along those lines. Which means all you need to be able to do here is just go to your table. And what is one thing that we definitely can plot? Well, where's your asymptote, guys? All right. That's fine. And that's all you got to be able to do with these. Now, let's look at another one that's within parentheses then. Okay? Take a look at this one. In this one, see how you are in parentheses? Okay. So that means that what is your H value? -2. Good. All right. So your H value is -2. No, there's no shift to these. Yeah, the other one K would have been 0. Okay. Or in this one K is 0. So your H is -2. And B is 5, so it's greater than 1. So it's going to be up this way. Can be one of those two, depending upon where you're at. Okay. Because this. Oh wait, no, that's down and right. So when you're going, you might have to do the change of base thing. So type that one in. Watch your parentheses here. Where is this? No, I don't know why it's not graphing on here, because it's... Well, I don't know why it's... It should work. There's no reason why it should be working, so you've got it right. Justice, you're using the 84 plate, right? No. Switches, I don't know why it's not. It should. Unless there's another way of setting up the parentheses here. That's just. I haven't seen that work through. I need that. You don't. I would never do that. See the, you get the sarcasm there? Sure. Yeah. All right. So hopefully, when you plot this one in, if it works right. I've got that vertical asymptote at -2. My table is allowing me to go at -1 and 0. At 3 it's 1, and I'm going like this. That's basically all I got to be able to do. Okay. When we're doing the graphs on logs, a couple of things you want to be able to point. You should be able to find at least 2 points that make sense for an ordered pair. Plot them. And I'm not even going to bother with the graph paper on these things. So when you plot yours on your sheets of paper, label the 2 points, because you should always be able to find 2 points that make somewhat sense. And then make sure you label where your vertical asymptote is. Alright? Because the rest of stuff just rather just using your calculator. Okay? That makes sense? Let's try another one. No, and I just want to do the graphing part today. Try those two real quick. Label out a couple easy points. We're where your asymptotes are. Yeah, you'll be able to find. You should be able to find easy points with both of these. Yeah, you can find some easy points with both of those problems.
Okay, yeah, no.
Probably going to record the dead airspace right now. So just remember, when you're working on these problems, if you do not see, if you don't see any parentheses, that, or especially around the x value, that means the h is equal to 0. Once you see parentheses, you know that what's inside of it, the opposite of that is your value of h. Okay? Preguntas. Taria, Aurora, yes, ma'am.
Can you put parentheses on the right side of it?
Yeah, absolutely. Yeah, you can have something like that where if this was an x plus 4, plus 5, you could do that. That's fine, because then if you want to think about what that graph would look like, you probably have that on your calculator still. You just tack on a plus 5. You'll notice that all that happens is the graph just shifts up 5. The asymptotes don't change or anything like that. Instead of being here at -3 and 0, it would be at -3 and 5. That's all. It just moves them up 5 spots. Okay? It's a good question. But you will see that. You will see that from time to time with an H and a K. But remember, all I'm asking you guys to be able to do is label out a couple of points and show your asymptotes. All right? What I'm going to give you guys today is just this simplistic worksheet. Now, on this worksheet, just so you guys see what's going on this worksheet, rewriting equations in exponential form, piece of cake. I'm not going to worry about calculator work. Evaluate without using a calculator. Basically what I want you to do here, remember yesterday when we said log base 3 of 27? What did we do to simplify that? Yeah, and then just rewrite it, all right? Yeah, we wrote it into that log base form. So it was log base b of x was, I was kidding. We always put in that equals x for all those problems, and we rewrote it in exponential form and simplified through, okay? So try and do that. Yeah, because here, if you look at log base 3 of 27, what's the answer going to be?
The answer?
Yeah. 3. Remember, you can look at that and say, I got to rewrite 27. Come on. I got to rewrite 27 to have a base of 3. So that's 3 cubed. So your answer is 3. Okay. So try and do some of those. I don't think you'll have an issue with that. I'll have you do the graphs. That's about it. Even the inverse stuff, it just kind of gets to be whatever. So we'll go through a handful of them. We'll get that back to you. You're good.